What's up guys, Daniel here. In today's video, I'm going to be talking about state machines. How you can use them in your game, why are they useful, and how can you implement one in Godot. So let's get right into it. First of all, what even is a state machine? A state machine is basically a set of states. For example, as you can see here, you can eat, sleep, and code, and the transitions between those states. These are the two main parts of a state machine or an automata or whatever, or they are called by multiple names. And for example, in this little state machine, we have three states: eat, code, sleep. And for example, we have an entry point here. So we start coding, and if we're hungry, then we go eat. Once we're full, we go back to coding. Once we're tired, we go to sleep. If we're hungry, we go back to eating, then we go back to sleep again, and so on and so on. Now, why is this useful? With this kind of architecture or model, you can very easily model more complex behaviors. So for example, let me just show you an example. Even, for example, this is a state machine for the TCP protocol. I mean, if you know networking, you might have heard of it, but I mean, it's a pretty complex protocol, but it can also be explained pretty nicely, with just a state machine and how you can transition between states. Now, to show you why it is useful, consider doing something like this without a state machine. Well, your code would look something like this. Let me just go here, open Paint. Let's not spoil anything. So if you were to do it without a state machine, I mean, it would be something like, well, if hungry, then do this. But yet again, okay, we then eat. So we eat here. Here's the eating block. But the point is that you would have a bunch of if statements scattered around your code. And your code would look like this. So a bunch of indentation, and it would be very hard to track your code, where did the bug happen and all of these things. And that's especially when the behavior of your player or your enemy or something like that gets more complex and complex. Your code will become larger and larger. If you do it like in a traditional way, line by line, checking things, and a lot of indentation will happen, and it will be very hard to read and follow, especially if you're working with others. I mean, if you're just working by yourself, you can get away with these things, but even though it's nice to get familiar with these concepts. Let me see if I'm recording my voice. Okay, I'm recording my voice. It's nice to get familiar with these kind of concepts either way. What else did I want to mention before getting into the implementation? And yeah, this is not just for games. This is a widely used model, state machine. So I actually really recommend looking into it, how you can implement it. I'm going to show in this video one implementation of it. There are many implementations. Actually, I stole this implementation. I didn't write it. I didn't write all of it myself. I will give credit to the guy I stole it from. I don't remember his name right now. I leave a link in the description. So what is my state machine about? So what are we going to be talking about in this video? Let me just show a quick demo. Hopefully, let me just check some things. Yeah, hopefully it will work. Basically, I have a big maze, and inside the maze I have some kind of creature that follows you. And that creature has some kind of behavior. When should it follow you? When should it attack you? When should it just, hide from the player and things like that? I'm falling in the sky. So as you can see here, we have this huge maze, and shortly something should come chasing me. Yeah, she's coming. She's somewhere here. Okay, oh, there she is. Okay. I didn't expect her to come from behind. So as you can see, there she is. She's following us and things like that. And when I go close to her, yeah, I should have gave you a warning about the jump scare. A jump scare happens. I gotta fine-tune that jump scare. I'm not really liking the way it is right now. So yeah, this is basically it. So how can you even model something like this. So for example, see, if I come inside here, this is a safe zone. She goes away. And then if I go outside again, she comes back and things like that. How can you even do something like this? This is where state machines come into play. So let's take a look at how they are implemented, how you can do something like this. But first of all, quick shout out to myself. Let me go back to the browser. This is all for game I'm making. It's called The Final Shift. You can wishlist it now on Steam. You play, it's kind of a horror, psychological horror. You play as a janitor, cleaning up in a building, but things get kind of weird as the story unfolds. The game, but you realize that there's something messed up, and I did some fourth wall breaking also. I think it turned out pretty well. So if you're interested, you can check it out on Steam and you can wishlist it. I would highly appreciate it. All right, let's get into the implementation. So let's just take a look at the state machine of this chaser right here that I have in my game. So we enter, so this is the start. We start by chasing the player. And then, as you see, we have some kind of other states that we can transition to. So, for example, if we are, first of all, in the chase state, and the player is in a safe zone, then just go into hiding state. Otherwise, just, chase the player. If the player is within action distance or attack distance, then attack the player, and from the attack state, instantly transition to the hide state. So once this is over, it's finished, we don't do anything. So this is, by this I mean like do nothing, or it doesn't require some kind of condition to transition. So once the attack is done, go back to hiding. And from the hiding, if the player is in the danger zone, go back to chasing, and so on and so on. Now you see here that there's like a line here. This is usually a notation to mark the entering. So how does one go from one state to the other state? So for example, if we go back to the TCP example, so for example, if we are in the congestion avoidance state and there's a timeout, we do these things. So we set the threshold and so on and so on. So this is basically, if this event happens, if there's a timeout, do this and transition to the other state. So the same thing here. If the player is in the safe zone and we're in the if we're in the chase state, get a random position and go to the hiding state. So this is the large overview of the state machine, and let's see how is this implemented in code. So first of all, we need to declare a state. This is what it looks like. We have something called a normal state. So for example, chasing the player, hiding from the player. What should be done continuously? We have an enter state. What should we do when we enter this state? So for example, get a random position. When we enter the hide state, get a random position. And we could also have a leave state. So for example, if we're done with attacking, go to the hide state. That could be a leave. I mean, not really, but we could do something like this, where if we're done with hiding, emit some kind of sound when we go to another state. And then we have this kind of like constructor over here where we just set the variables. Then we have the state machine itself. This describes, this is basically the logic behind transitioning between states. So first of all, we have a function to add a state. So we need to define our state. This takes in as parameter the three functions that we discussed. And this is just some checking. I didn't write this code. Basically, we check here if we have a normal state. First of all, also, I forgot to mention, we have a state dictionary. So basically, this is where we store all of our states. So this would look something like this. This is an associative container, so key value pairs. It would be something like, chase, and then the state of the chase, hide, state of the hide. And the state of the hide would include the normal function, the enter, the leave functionality, what you did do. So it basically looks something like this. All right. And we also have a variable to keep track of the current state we're in right now. Okay, so with this, we can add states. Basically, we check, okay, we got a normal state, or whatever you want to call that, the thing that gets run always, almost every frame. If it's empty, then just get the enter state. This is also not bulletproof because the enter state could also be null. But anyway, it works good enough. And basically, we just add it to the dictionary. The way we do that is we take the method name. So this get method returns a string name. So a string, basically the name of the function. So we map the name of the function to the state itself. And here we create a new state for it. All right. Here we can set an initial state. So this will be the starting state. So for example, this is where we define this, that we start in the chase state. Basically what this does is it sets the state to the state that we give it in the parameter. Let's look at the set state function. Basically, this is the core of the logic. So this is how we actually, let's look at the transition function. So what we do here in the transition is we get the state that we want to transition to, we get its name, so that we can fetch it from the dictionary. So if we have this state, then we set, we basically transition to that state. So by the set state function. Let's look at how this set state works. This is the main logic behind it. So we look at our current state and we have the state name that we want to transition to. First of all, we need to call the leave function for that state. So for example, before transitioning from the hide state to the chase state, for example, we might want to call some kind of function. So we get that function by looking up in the dictionary the current state, for example, hide state, getting the leave functionality of that, and just calling it. We check if it's a valid function, and then we call the leave function. Then we enter the other state, so we can set the current state to the state that we're transitioning to. We call the new state's enter function, so we get the enter callable. These are just some print statements, debugging purposes. Then we call the enter function. So we have the leave functionality, so we call the leave function, and then we call the enter function. But where do we, for example, actually chase the player? This happens here in the update function. So this update function gets a delta parameter. So for example, since we're calling this every frame, if you're familiar with game engines, we have this concept of delta. So the time elapsed between every frame. So between the previous frame and the current frame. So for example, it might be 20 milliseconds or 0.1 milliseconds or something like that. So basically, we just do some checks. Okay, do we actually have a current state? Does it have like a function that needs to be called every frame? If so, call that function. That's basically what's happening here. So we fetch it from the dictionary, we call the normal. So call, and we pass in this delta parameter. So this is basically the idea. So let's see how is this chaser implemented. Let's go to the chaser script. How do you use this? First of all, you set a state machine variable in the ready function or in the init function, however you want it. First of all, we create an object, assign it to the state machine variable. We add all of our states. So we have our chase, attack, hide from player. Actually, you see that I have some other states commented out. I actually realized while making this video that I initialized those states, but I actually didn't use them. So they were like dangling states. So they were like here, but nothing connected to it. So yeah, a good thing that I made a video about this. We set the initial state, and then we just do some other setup. That's it. This is basically what you need to do, set up the state machine. So for example, let's look at the chase function. So here it is. I have a chase function, and very important thing, if you have something that needs to be done every frame, you can go to the physics process or the simple process function and insert this line, state machine.update data. And what will this do is this will call the update function for the state that we're currently in. So for example, chase the player, go towards the player. Let me see if I'm still recording, because it has happened to me a lot that, I recorded for 15 minutes and actually I wasn't recording. All right. So you also need this. And then, for example, let's look at the chase. We have some logic here. Get the distance to the player. And for example, right here, if the distance to the player is less than the action distance or the attack distance, then we check if the player is inside, things like that. But if this condition is true, so if we're within the action distance, transition to the attack state. So this is where it is actually implemented. If we're in the action distance, transition. So if within the action distance, transition. And basically that's it. And with this, you can it's much more easier to, for example, debug your code. So maybe, for some reason, the guy doesn't want to attack the player. Well, you already know instantly that, okay, where can we attack? Where do we enter the attack state? We can enter the attack state from the chase state. So there must be something wrong either with this or either with something here. So you instantly limit it down where you need to look inside your code, where you need to debug. And this is very important. It makes debugging much faster. And this is basically it. You just set some kind of condition. If this happens, then transition to this state. And that's basically it. Let's look at another one. Let's look at the attack. So here, once we go to the attack state, we just, do some things. And then we transition to the hide from player state. And that's basically it. And if you want some kind of enter or leave functionality, you just define the function. So for example, the hide enter, this one, get random position. This is the enter state of the hide function. So we just get a random position and you just assign it here in the initialization of the state. So that's basically it. And yeah, that's basically it. Thanks, Johnny, for requesting me this video. I saw your comment. Thanks a lot. Yet again, if you have any questions, leave a comment and I'll be happy to answer it. If you're interested in the game, yet again, it's out on Steam. You can wishlist it. I think it's a pretty good game. I think it's turned out pretty well. I want to talk more about it, but I don't want to spoil the story. But there's some kind of plot twist at the end. All I'm gonna say is that it has some kind of cognito hazard elements. Taken inspiration from these analog horror videos. So if you're interested, you can wishlist the game. I think it's pretty cool. I should update these screenshots actually, because the game looks a little bit different now because I updated the texture to be more pixelized or more pixelated. So yeah, that's about it. Thanks for watching the video, and if you have any questions, leave a comment, things like that. Look out for the game. It will be soon released. It's almost ready. I mean, there's some things, but it's pretty close to being ready. So thanks for watching, and I'll see you in the next video. Goodbye.